Hello, chemistry students. Today we're going to go over the heating curve of water. So flip your notebook so it's landscape style, so you're taking up the whole thing. You did a lab on this previous, and where we melted ice. And we're going to expand on that. So you're going to draw a graph. So you're going to need to label your axes right here. And you're going to label this temp. And this is in degrees Celsius. And you're going to label this heat, which is energy, over time. Heat over time. When we were in chemistry class and we were doing the lab, we started with ice that was melting. And so I'm going to draw a plateau right here. We started with melting, and we noticed that the temp didn't change. And then, after all of our ice was melted, you probably noticed that the temperature started rising until we got to another point where it stopped rising and it plateaued again. And so we had something like this in lab. And so we said that this is melting. And melting, we said in class, is a solid to a liquid. So this is melting. And we have liquid right here. So that's the liquid phase. And then here we have boiling, or chemists like to call it vaporization. And that is from a liquid to a gas. We'll use both, vaporization or boiling. And so that's what we had for our lab. And we talked about how this is going from a solid to liquid. And we said that the energy for that had a special name. We called that energy E phase energy. And we said that this was also E phase energy. And then we called where the temperature was rising, where it was liquid, we called that E thermal energy. There's some parts of this graph, though, that we didn't see in lab because it's hard to see these parts in the graph. The one part that we didn't see is that from melting, right, up to melting, we have solid. So this right here is a solid. And remember, in a solid that we have particles that are vibrating. And so if this is our temperature right here, and this temperature right here, since this is melting and it's water, this is going to be 0 degrees Celsius. because it's melting with water. Anything below 0, it's a solid. And you notice that the temperature is changing right here. Temp is changing. And then heat is still being added over time. So solid particles at this stage would be vibrating. But solid particles right here would also be vibrating, but they would be vibrating a lot. But still vibrating because they're solids. But here we have a higher temperature, and here we have a lower temperature. This also is considered E-thermal. The energy is thermal energy, just like here. For a liquid, at this point, you would have particles that are moving, right? They have a certain temperature here, but up here, they would be moving much faster. Still a liquid, but they're moving faster. E-thermal energy. And then after this plateau, we do have another place where we would have seen a rising of temperature if we were able to have equipment that could measure that. And at this point, this is considered a gas. And this is, again, energy thermal for that gas. And again, if we had this gas that we were looking at, it would be probably all over, not within the container anymore. But it would be long here. And at this point, they would be really long. They would be even faster because our temperature is rising. Okay, so temperature is rising. This is considered E-thermal energy. So we're going to write that down here. And just so you know, you can stop and start this anytime. I would if I were you, so to be able to take the notes correctly. So E-thermal energy, and this is, of course, energy. I'll write that just in case. This energy is due to the speed of the particles. So it's due to the speed of the particles. This is temperature, what we know as temperature. Right? That's temperature. That's E-thermal energy. So if you have something that's a higher temp, it's going to be going faster. Lower temp, it's going to be going slower. So high temp, we know that as fast. And low temp, we know that as slow. Okay, fast and slow. And so here we can see, here's temperature. So when it's a solid, the temperature is rising. When it's a liquid, the temperature is rising. And when it's a gas, the temperature is rising. We can see that on our graph. And we saw this in lab from here to here. But we also have this thing called E-phase. And this is probably new energy for you all. And phase energy is energy, so E phase, okay. E phase energy is energy due to the arrangement of particles. And this is phase. So what do I mean by the arrangement? What I mean by that is when we're melting, the temperature is not rising because this energy is breaking apart the molecules from a solid to being able to move like a liquid, or it's breaking apart the molecules of a liquid to be able to become a gas and leave over here. So you can think of it as, so let's write this. We'll say particles break apart going from solid to liquid and from liquid to gas. Also, particles come together if you're going from a gas to a liquid or a liquid to solid. So what do I mean by that? Well, so melting, you have at this point, right? At this point, you only have solid particles. They all look like this. But at this point, you only have liquid particles. They all look like this. So in between here is this phase energy being used to break apart that solid into a liquid. Likewise up here, so right here you have only liquid, and by the time we get here, we have only gas. And so these particles, during this time period, remember, energy is still being added. Energy is still being added. But these particles are being broken apart from a liquid to a gas. I'm going to stop there for this video for the heating curve of water. And I'm going to do one more video highlighting what these look like at 3 different points and what these look like at 3 different points. So also watch that video as well.